Good morning, student. Here, chapter number 3, pair of linear equation in two variables. Now, it is the last part of this chapter, and in this lecture, we are going to solve some important example from exercise number 3.6. So, let me solve that. Here, given in exercise number 3.6, solve the following pair of equation by reducing them to a pair of linear equation. Means we are going to use here reducing method. So let given for the given equation, linear equation, here you can find 6x plus 3y is equal to 6xy and 2x plus 4y is equal to 5xy. Here you can see that the equation given equation are in not a linear form. So first we have to convert it in a linear form. For that, here you can see that whenever we take this type of equation, first term has a x variable, second one is a y variable, and third term is always constant. But in this linear equation, you can find that there is given constant term as x and y in multiplication form. So we cannot solve it by easily, so we have to convert it or we have to reduce it in a linear form. So that let first we how can we convert it in a linear form? So that we have to follow some steps. Here given that 6x plus 3y is equal to 6xy. For this example, here given that 6x plus 3y is equal to 6xy. So what we do? We that here you can see that here given x into y. So we divide both the side, means LHS and RHS by xy. What we do? We divide LHS and RHS by xy. So here now giving the denominator to both the term, we get 6x by xy plus 3y by xy, and here xy will be cancelled, then equal to 6. Here you can see that x will be cancelled and y will be cancelled. Then remaining part, as you can see here, what will be? That it will be 3 by x plus 6 by y is equal to 6. Now what? We know that how can we reduce it in a linear equation? For that we assume 1 over x is equal to any other term as a or any else variable, and 1 over y is equal to b. And putting these in this equation, we can find linear equation. By this way, first we convert it in a, or we reduce it in a linear form, and then we solve it and we find the value of a and b, and after then from the value of a and b we can find easily the value of y and x. So let me follow these steps. So now solution of given example. So that in first equation 6x plus 3y, if we divide x by y, then we get 6 by y plus 3 by x is equal to 6, and we assume 1 over x is equal to m and 1 over y is equal to n. Then we get equation as given here, 3m plus 6n minus 6 is equal to 0, equation number 1, and as well as in equation 2, 2x plus 4y plus is equal to 5xy, we divide both the side by xy, then we get such equation, 4m plus 2n minus 5 is equal to 0. Now using one of the method, elimination method, cross multiplication method, or substitution method, we can find the value of m and n. Now we have equation 2 as here given here. By cross multiplication method, we get m divided by minus 30 minus 12 is equal to n upon minus 24 minus in bracket minus 15 and 1 upon 6 minus 24, and hence At last we get the value of m by comparing the constant ratio and the ratio of m, and after then for the value of n, the ratio of n and constant ratio, we can find the value of m and n. Here we get the value of m as well as we can find the value of n. N by minus 9 is equal to 1 over minus 18. Then we get n is equal to half. Now m is equal to 1 and n is equal to half. Then m is equal to 1 over x, that is 1, and n is equal to 1 over, that is half. Then we get x is equal to 1 and we get y is equal to 2. Hence x is equal to 1 and x is equal to y is equal to 2. By this way we can find the value of given any pair of linear equation by this way. Now let me solve some problems from question number 2. Formulate the following problems as a pair of equations and hence find their solution. First we have to write this the problem in a algebraic representation. Now Ritu can row downstream. Downstream means with the flow. Downstream means with the flow. Means we know that if a boat goes is with the flow, let me assume that its speed is x in still water. The speed of boat is x in a still water, kilometer per hour, and the speed of water, flowing water, is y, kilometer per hour. If downstream means with the flow, the speed of boat will be x plus y, because the boat has its speed and also it flows with the flow. Then it has speed x plus y, kilometer per hour. Hence it is a speed when Ritu can row with the flow. And also about upstream, there is this by this way. Here the boat rows in the opposite direction of the stream. Then its speed of boat and it is speed of stream. Then the speed of boat is reduced by x minus y, kilometer per hour. So it is a speed of boat in upstream. So here given that Ritu can row downstream for 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and speed of current. So that solution, let the speed of Ritu in still water and the speed of stream be x km per hour and y km per hour respectively. Speed of Ritu while rowing upstream, that is x minus y km per hour, and downstream x plus y km per hour, y as we know that we have discussed. Now let, according to question, here given that in downstream Ritu complete the distance by rowing in 2 hours and 20 kilometers. So we know that speed is equal to distance by time. So here we can find distance is equal to, we multiply time here, so we get time into speed is equal to distance, that we have here. From that we can find the first equation, x plus y is equal to 10, and as well as next equation for upstream, 2 into x minus y is equal to 4 hours. So we can find x minus y is equal to 2. Now we have two equations as here given. Adding equation 1 and 2, we obtain 2x is equal to 12, x is equal to 6. Putting this in equation number 1, we obtain y is equal to 4. Hence Ritu's speed in still water is 6 km per hour and the speed of current is 4 km per hour. Now next example. There is given 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by one woman alone to finish the work, and also that taken by one man alone. Now here given one work, embroidery work. One work it can be finished by 2 women in 5 men in 4 days, and also the one work is completed by 3 women and 6 men in 3 days. Now first we have to find the capacity or work capacity of one man and one woman, to find the days taken by one woman and one man to complete one work. Now first we assume that here we want to find the days that one work is done by one woman and one man. Then we have to take x as let the number of days taken by a woman and a man be x and y respectively. Here x and y are days that one man or one woman can complete. Now therefore the work done by a woman in one day is given by 1 over x. The capacity that a woman can complete one work in given days, that is 1 over x. As well as we can take work done by a man in one day is equal to 1 over y. Now we want to find here given the first line, from the first line we can find such equation here given that according to the question, the work done here is equal to 1 work here. 2 by x means work done by 2 women, that is multiplication of 1 over x and 2 by x, and multiplication of 5 men and capacity, that is 1 over y. Then we can find 5 by y, and it is done in 4 days is equal to 1. Hence 4 can be removed here, so 1 over 4. Then we get 2 over x, 5 over y, and 1 over 4, as here you can see that. As well as from the second line, while 3 women means 3 over x and 6 men, that is 6 into 1 over y, that is 6 over y. The work done by in 3 days, 3 is equal to 1 work. So here we can find 3x by plus 6y 6 by y is equal to 1 over 3. So we have two equations. Now let me assume the value of 1 over x is equal to p and 1 over y is equal to q. In this equation we obtain such equation here as given. By simplifying these two equations, we can find 8p plus 20q is equal to 1 and 9p plus 18q is equal to 1. Now let solving this equation by one of the method, by cross multiplication method, as we know that p over minus 20 minus in minus 18 is equal to q by minus 9 minus in bracket minus 8 is equal to 1 over 144 minus 180. After then we can find such a ratio p by p upon minus 2 and is equal to q by minus 1 is equal to 1 over minus 36. Hence by comparing p this ratio and constant ratio, then we can find p over minus 2 is equal to minus 1 over 36 and q over minus 1 with the constant ratio 1 over minus 3 over 6. Then we get the value of P is equal to 1 over 18 and the value of Q is equal to 1 over 36. Now here we have the value of P and Q. Now substituting this value in the assumed value, then we get P is equal to 1 over X, then 1 over 18, and Q is equal to 1 over Y, then is equal to 1 over 36. Taking inverse, then we get X is equal to 18 and Y is equal to 36. Hence the number of days taken by a woman to complete one work is 18 days, and the number of days taken by a man is 36. That one work can be done by one man in 36 days. Now let one more example. Ruhi travels 300 km to her home partially by train and partially by bus. She takes 4 hours if she travels 60 km by train and the remaining by bus. If she travels 100 km by train and the remaining by bus, she takes 10 minutes to longer. 10 minutes longer. Find the speed of the train and the bus. First we have to assume the speed of the train and the bus. So that we have to assume the speed of train is u and the speed of bus is v. Now here total distance is 300. The total distance is 300 km. In first problem, there is given that she first travel by train, that is 60 km. So that remaining distance is 240 kilometers by bus, and she takes 4 hours, and hence in second she travels 100 kilometer in a train and remaining 200 kilometers in a bus, and she takes 10 minutes longer, means 4 hours and 10 minutes. So first we convert it in a simple form by using the formula that we know that speed is equal to distance upon time. We want to find time, so t is equal to distance by speed. So let me using by this formula we can find solution. Let the speed of train and the bus be u km per hour and v km per hour respectively according to the given information. 60 by u, how? 60 by u, how can we find this 60 by u? As you know that the speed, the time taken by the time travel by train, t is equal to, we say t1 is equal to 60 kilometer divided by u, and t2, that is time taken by traveling by the bus, that is distance divided by speed. So t1 plus t2, and the total time is given by 4 hours. t1 plus t2 is equal to 4 hours. So we get 60 by u plus 240 by v is equal to 4. So it is equation number 1, and as well as for equation number 2, 100 kilometers traveled by train, that is the time t1 is equal to 100 divided by the speed of train is u, as well as t2, that is distance 200 travel by bus and its speed is v, or t1 plus t2 and takes 10 minutes more. Means here we find 4 hours and 10 minutes. So we can convert it in a hours. So we can find 25 by 6. Now let solving these two equations, we can find value of u and v. First we have to assume the value of 1 over u and 1 over v by some variable. Putting 1 over u is equal to p and 1 over v is equal to q. In this equation we obtain 6p is equal to 240q is equal to 4 and 100p plus 200q is equal to 25 by 6, and hence the equation reduced in 600p plus 1200 q is equal to 25. Now equation 3 and 4 we can find the value of p and q. Multiplying equation number 3 by 10 we obtain 600p plus 2400q is equal to 40. Now from equation 5 and 4 we obtain, subtracting equation number 4 from 5 we can get 1200 q is equal to 15, and hence q is equal to 15 by 1200, and after cancelling common term we can find 1 over 80. Now q is equal to 1 over 80, and also we can find value of p by substituting in equation 3 we obtain 60p plus 3 is equal to 4, then 60p is equal to 1, and hence p is equal to 1 over 60. Now we have assumed p is equal to 1 over u, then we put 1 over 60, and as well as q is equal to 1 over v is equal to 1 over 80. Then the speed of train u is equal to 60 km per hour and the speed of bus v is equal to 80 km per hour. Hence the speed of train is 60 km per hour and the speed of bus 80 km per hour. By this way you can solve some example from the exercise number 3.6. There are given some example. In first example 5, 7 and 8. The simple form you just use reducing method, and after then you put any one method, substitution method, elimination method, or the given cross multiplication method. You can find the value of the given unknown variables. Hence by this way we have completed this chapter, and if you have any doubt, if you have any doubt from this chapter, then you discuss it with me that we can solve it